I'm gonna work this problem out. In this problem, we have that we want to find the energy that has been transferred to a 2.5 kilogram block of aluminum, and this is being heated from 20 degrees Celsius all the way to 75 degrees Celsius. One thing that I do want to note in here is that the change in temperature will be the final temperature minus the initial temperature, which in this case, the change in temperature is just going to be final temperature, which was 75 degrees, to 20 degrees. If we subtract that, we get 55 degrees Celsius. Just like I said in class, it would be so beneficial if you guys were to draw a T chart, essentially, in which you can write your knowns and your unknowns as well. Okay, now in here we know the mass. The mass is given to us as 2.5 kilograms. Okay, that's what we have in there. We are also given the change in temperature. Change in temperature is 55 degrees Celsius. Specific heat, it's also given as 900 joules divided by kilograms times degrees Celsius. So what we're looking for is capital Q. We know that capital Q in this case, which is the energy transferred, is equal to mass times specific heat times the change in temperature. At this point, all we have to do is just substitute the values that we have. Now, don't forget to carry over your units all the way through. So we will have Q is equal to 2.5 kilograms. Okay. And then the specific heat, that's 900 joules divided by kilograms times degrees Celsius. Change in temperature turns out to be 55 degrees Celsius. So now I can start canceling things out. So I know that a degree Celsius cancel out. Kilograms also cancel out. And my final unit is just joules. When you multiply everything out, 2.5 times 900 times 55, you end up with 123. Let me just double check. 123,750. So 123,750 joules. And that is the answer that we are looking for. Okay. Take a look at this. Pause it. Do it again if you have to. I'm gonna do another problem. Okay.